Welcome to week 7. Now in this week we are going to learn some more tests for convergence, and before that we will look for a new definition, right? And the definition is absolute convergence. Well, before going into that definition, there's something that we need to see when you are given a series, right? So when you have a series, let's take this one, this series, negative 1 to the power n plus 1. Let's have 1 over n squared, right? So if we relate this series along with this general format, then an will be the sequence of negative this term, right? So an will be the sequence of negative 1 to the power n plus 1, 1 over n squared, right? And n starts at 1. So when you have this sort of a series, we can see that there is another series that can be extracted out of this original one. How can we do that? We can just get the absolute value of each and every term in the sequence an, right? So according to this one, this series will be the absolute value of negative 1 to the power n plus 1 n squared, right? So the series, the new terms of the series will be the absolute values of the previous one. So now if we expand this first one, it will be equal to 1 over 1 plus minus 1 over 2 squared plus 1 over 3 squared plus minus 1 over 4 squared likewise. Okay, this is 5 squared. For all the odd numbers you will get plus values, and for all the even numbers it comes along with the negative sign, right? And when you take the modulus of each and every term, that means we are taking the modulus of all these terms, right? So it will be just equal to the positive terms of this series, right? So it's like we are just taking the modulus one by one, right? And the definition is, for the definition we have a word called absolute convergence, or in other words we say that the series sigma an is absolutely convergent when the series of absolute values, that is this one, is convergent. Now let's take an example. If you consider this series, the one I mentioned above, this one, right? We have this one. So here the an terms of this particular series is equal to negative 1 to the power n plus 1 over n squared, right? And the absolute values of this series is equal to the absolute values of an, and that is equal to just 1 over n squared, right? Because when you are taking the absolute values, the negative terms will this negative coefficient will vanish, right? So all the terms will be positive. Okay, so and we can see that from that P series test, we can see that this series is a convergent series. So basically the absolute values of this series is convergent, right? Or in other words, we can say that this is an absolutely convergent series, because the absolute values of this series is convergent. Okay, and in the next video we will go over some more examples and theorems related with this absolutely convergent series.